Just a quick recap. Yesterday, we learned how to graph functions by rewriting them in function form and then using an XY table. So for example, let's say I had 3y equals 2x minus 6. And I wanted to graph this thing. Well, you need some coordinates to graph it. So the first thing to do is to rewrite it in function form. That would mean to get y by itself. So if you divide everything by 3, you end up with y equals 2/3 x minus 2. Ladies and gentlemen, I hope you're all keeping up with this in your notebook. So this is a function form equation now. Now, if I wanted to graph this equation, I would simply have to make an XY table and plug in some numbers and pull out some answers. So if I go to an XY table and I have a fraction as my coefficient of x, once again, I have a fraction as my coefficient of x. So if you have a fraction, you could always use 0 no matter what. But if you have a fraction, it's good to use the denominator and maybe the negative denominator, or maybe the denominator times 2. All right? So if I plug in 0, it's going to look like this. It's going to look like this where I plug in 0. Now if you work this out, 2/3 times 0 is 0, and 0 minus 2 is negative 2. So when you plug in 0, you get out a negative 2. And ladies and gentlemen, that is your first coordinate. Let's say you wanted to plug in 3. It's going to be the same thing, but instead of 0, you're going to plug in a 3. So there it is, 2/3 times parentheses. Now let me plug in a 3 right there. And it works out nice because the 3 and the 3 cancel out. So you really have 2 take away 2, which is 0. So when you plug in a 3, you get out a 0, and that's another coordinate right there. In reality, you only need 2 points. The reason why we do more is to feel comfortable about the line that we created. So let me do one more. Whoops. So let me scroll up a little, and let me plug in negative 3. That's going to be 2/3 times negative 3 minus 2. So the 3's cancel out again, but inside the parenthesis, you have 2 times negative 1. You still have that negative sign, minus 2. So when you say 2 times negative 1, that's really a negative 2. Minus 2, you get a negative 4. So your output is negative 4 for the input negative 3. So let me just show you what this looks like so far. Let me move this to the side. If I did go to an XY plane and I graphed the coordinate 0 on the X and negative 2 on the Y, I'd end up with a dot down here somewhere. And if I went 3, 0, it'd be over here somewhere. And if I went negative 3 and negative 4, negative 3 and negative 4 would be down here somewhere. And as you can see, it does line up. I mean, not perfectly. That's only because I don't have a perfect graph. But that's what we learned yesterday, how to graph equations by using an XY table. We first make sure that the equation's rewritten in function form, which means get y by itself. And then after that, you make an XY table, you plug in numbers, pull out answers, graph your coordinates, and you just draw a line through them with arrows on it. In addition to yesterday's lesson on graphing function form equations, we also need to be able to determine, just by looking at an equation, whether it's a linear equation or a nonlinear equation. In other words, will it graph a line or will it not graph a line? Will it be some other type of graph, some type of curve, or something else? So, ladies and gentlemen, you all need to copy this down in your notes today. Linear versus nonlinear. Now listen to this. To determine if you have a line, make sure that your x is not being multiplied by any other variable. X is not being multiplied by any other variable. Not by a number, but any other variable. Okay? So what does that really mean to make sure that your x is being multiplied by any other variable, that not being multiplied by any other variable? That means, if you look over here to the side, it means no letters multiplied together. You don't want an xy or you don't want an x divided by y. Because if you have an xy or x divided by y, if you have variables being multiplied together, then you're going to get something else. It's not a line anymore, okay? So let's go back to our notes that I want you guys to copy down. And hopefully you guys understand these notes. Once again, to determine if you have a line, you got to make sure that x is not being multiplied by any other variable. Okay, and in addition to that, also make sure that no variables are squared or cubed, or has any power for that matter. So you don't want x squared, you don't want y squared, you don't want x to the third or x to the fourth or y to the fourth or y to the fifth. No powers on any variables. Because if you ever have a power on a variable, it's no longer a line, it's something else, it's some type of curve. Okay? So I would like you guys to copy this down. I want to hit pause right now so you guys can copy this down. And we have 1, 2, 3, 4, 5 equations that we're just going to classify as either yes, it's a line, or no, it's not a line. Yes, it's linear, or it's non-linear. Okay? So copy that down. If you're doing this from home, hit pause, copy it down, try to do it. Determine if each of these linear or non-linear, linear or non-linear, and then we'll go over them right now. So you should have these notes down. You should understand what they mean. So the question is this guy a line or not a line? Is this guy a line or not a line? It is a line, okay? Now, does it have x multiplied with y? No, it has x multiplied by 2, but not multiplied by y. Mario, quit liking my videos. Come on. Does it have a variable squared or to the third power? Does it say y squared? No. Does it say x squared? No. Right? So it's clear this is a line. So this one is linear. Okay? This one is linear. Or you could put yes, it's a line. Right? Now how about the next one? Is that a line? No. Why not? Because it has a y squared. Because it has a y squared. You can't have any variables with a power or variables multiplied with each other. How about the third equation right there? Is this one a line? Is this one a line? No. Why not? Because it has x times y. And remember, you can't have x times y, or x divided by y for that matter. Is this one a line? No. It has a power of 2 on the x. Shh. Is that last one a line? Yes, it is. There is no powers on the x or the y. The x's and the y's are not multiplied together. So it's that simple. As a matter of fact, if you wanted to graph this thing, you could get it in function form. You could get y by itself, and you could plug in inputs and pull out outputs. But we're not going to do that. We're just going to say, yes, it is a line.